This is Math 96, Quiz 2 topics. Power rules with negative exponents. I thought it might be helpful to start with just a quick review of the rule for dividing. And so if we had 2 to the 5th over 2 to the 2nd, our rule says that we just subtract the powers, so this would be 2 to the 3rd power. I want to show you why that is. So 2 to the 5th means 5 copies of 2 in the numerator. 2 squared would mean 2 copies of 2 in the denominator. And so we could cancel one of those pairs of 2's, 2 of those pairs of 2's, leaving just 3 2's on the top, or 2 to the 3rd. So that's how we get our 2 to the 3rd. If, on the other hand, we had 2 squared in the numerator and 2 to the 5th in the denominator, and we did our subtraction rule, we'd have 2 to the 2 minus 5, which would be 2 to the negative 3rd power. Let's think about that. This would mean 2 copies of 2 in the numerator, 5 copies of 2 in the denominator, and if we, again, canceled 2 sets of 2's, that would leave us with 3 copies of 2 in the denominator. Well, we have to have something in the numerator, so we can say that this is being multiplied by 1. So that would be 1 over 2 to the 3rd. And so another way to write 1 over 2 to the 3rd is 2 to the negative 3. Anytime you see a negative exponent, it really means that we're dividing by 2 to that positive power. Okay, so knowing that, now let's look at our 2 examples. The first one says, in parentheses, 3a to the 6th over b to the negative 3, that quantity raised to the negative 3 power. Anytime you have an exponent on the outside of parentheses, that exponent is applied to every single part of what's on the inside. And so what this means is we have 3 raised to the negative 3rd. We have a to the 6th raised to the negative 3rd. And we have b to the negative 3rd raised to the negative 3rd power. And so let's think about each part of that. First of all, 3 to the negative 3rd power, we remember that a negative exponent, as we've just seen, means that we're actually dividing by this. So I'm going to move that 3 to the denominator and make the power into a positive 3 instead. Okay, this one would be the 6 times the negative 3. So this is a to the negative 18. And this one in the denominator would be negative 3 times negative 3 would make positive 9. So this is b to the positive 9. Okay, let's keep on going from there. First of all, 3 to the 3rd just means 3 times 3 times 3. So that would be 27. So now we have a 27 in our denominator. It looks like the b to the 9th can stay put where it is. But this a to the negative 18, that negative power means that we should be moving this expression to the denominator and changing that to a positive exponent. So this becomes a to the positive 18 down here. We need to have something in the numerator, so we'll leave 1 up there in the numerator. And so we can write it this way, or if you want to write the numbers, the variables alphabetically, that would be 1 over 27 a to the 18th, b to the 9th. Okay, our second example might be a little bit easier. This is a product being raised to the negative 4 power. And so again, we're going to apply that negative 4 on the outside to each of the inside parts. So 2 to the negative 4, x to the 4th to the negative 4, and y to the negative 6 raised to the negative 4 power. Let's look at each part individually. The 2 to the negative 4th we can rewrite with a positive exponent if we move that to the denominator of a fraction. And so let's move this to 2 to the 4th in the denominator. Okay, here if we multiply the 4 and the negative 4, we'd have x to the negative 16th. And then here, y to the negative 6th raised to the negative 4th, we multiply those exponents and we get y to the positive 24. All right, so you'll notice we can do some simplifying. I'll start here with the 2 to the 4th. That means 2 times 2 times 2 times 2. So 4 times 4, which would be 16. I now have 16 in the denominator. This x to the negative 16, I can rewrite with a positive exponent by moving it to the denominator. And so that becomes x to the positive 16 down here. And then finally, the y to the 24th can stay where it's at because that exponent is positive. So this would be our final answer.